Hello, this is your instructor, Tom Porepsky, and we want to get started on Module 2, which deals with descriptive statistics. And at first we cover descriptive statistics dealing with tables and graphs. And right now we'll focus on categorical variables. Remember that a categorical variable is one where the outcomes are simply classifications or different types of an outcome. There is no automatic numbering system associated with a categorical variable, although we could arbitrarily put a numbering system on them. Variables like sex, male and female, or what rank in class you are, freshman, sophomore, junior, senior, what region of the country you were born in, east, north, south, west. Those are all categorical variables. The purpose of using tables and graphs is to put the data in a more organized and manageable form. Hopefully that way we can see trends in the data more easily, we can see where the data is located. You've all heard the old expression that a picture is worth 1,000 words, so a graph or a table sometimes allows us to see things that we might not have seen otherwise. So let's get started with categorical data. We can put categorical data into various tables. We can use a frequency distribution, a relative frequency distribution, or a percent frequency distribution. Or there's a couple of graphs that we could use, namely a bar chart or a pie chart. Let's start with frequency distributions. As the word suggests, frequency distribution simply counts the number or frequency of items in each category. It'll be easiest if we just use a specific example as we go along. Suppose a local restaurant occasionally surveys their patrons and asks them to rate their service. Suppose they give them 5 choices: excellent, above average, average, below average, or poor. We take a sample, let's say, of 40 patrons, and we got the following results. As it stands, this table is just a mass of ratings and doesn't tell us very much. But possibly by using tables or graphs, we can put it in a more manageable form that allows us to see trends in the data and so forth. First, we can put the data into a frequency distribution. There were 4 ratings. If you go through the table that we just looked at, there's 4 ratings of poor, 6 of above average, 14 average, 12 above average, and 4 excellent, for a grand total of 40. Note that the sum of the frequencies equals your sample size, in this case 40. If we like, we can go from frequency to relative frequency or percent frequency. Relative frequency simply calculates the proportion or fraction of items in each class. All we have to do is take the frequency in each class and divide it by n, your sample size, to get the relative frequency. Percent frequency takes the relative frequency and multiplies it by 100% to put it in percentage terms. That is, you simply move the decimal over 2 places to the right to go from relative frequency to percent frequency. Here are the relative and percent frequencies for this example that we're doing. If you don't see where those come from, we can go back quickly here to the original frequency data. Remember, we had 4 ratings of poor out of 40. Well, 4 divided by 40 is 0.1. So that's where the 0.1 comes from for the relative frequency of the first category. Move the decimal over 2 places to the right, and that's equivalent to 10% in that category. So we have 10% of the ratings are poor, 15% below average, 35% average, 30% above average, and 10% excellent. Notice that the relative frequencies have to sum to 1, or in percentage terms, to 100%. The relative frequencies have to sum to 1 is simply a way of saying that all of the data has to be accounted for in one of the categories. All 100% of the data must be there somewhere in the categories. We'll see in a later module that relative frequency is one of the most basic concepts of probability, and we will use it quite a bit. Let me go back for a moment to some of our tables here. You might also ask, well, what do I need? Do I need a frequency count? Do I need relative frequency? Do I need percent frequency? In part, that depends on what you're doing and what you're looking at. For example, supposing I had two classes of statistics and I come in after a test and I say, well, there were 4 A's in this class, but there were 7 A's in the other class. That is, I just give a frequency count as to the number of A's. That's actually not very useful information because I haven't told you how large the two classes are. If one class is bigger than the other, it might not be surprising if there were more A's in that class. So in that case, it would probably make more sense for me to use either the relative frequency or percent frequency of A's and not the frequency count. Okay, let's move to graphs. We've looked at some tables. Now we'll look at a bar graph, which more than likely you've seen in your life. You've probably drawn bar graphs in your life. You've certainly seen them in newspapers, magazines, textbooks, and so on. A bar graph gets its name because we're going to use bars to represent the different categories, the heights of the bars representing either frequency, relative frequency, or percent frequency, which will be on the vertical axis. The different categories will be on the horizontal axis. So you have a choice here. You can do a frequency bar graph that shows the frequencies, or you can do a relative frequency bar graph, or you can do a percent frequency bar graph. Make the bars of equal width, only vary the height. That's for comparison purposes. And we're going to separate the bars because with the categorical variable we have distinct categories. Here's a bar graph for a frequency bar graph for the restaurant ratings that we were just looking at. We had 4 ratings of poor, we had 6 ratings of above average, 14 ratings of average, 12 ratings of above average, and 4 of excellent. Notice that a bar graph gives us a certain visual appeal and a visual look at the data. You can quickly see by the highest bar where the greatest number of ratings were, in this case in the average case, the next highest the above average case. So it gives you a quick look at how the data is dispersed over these categories and where the greatest location of data is. If I had wanted a relative frequency bar graph or a percent frequency bar graph, the only thing that would differ is what I measure on the vertical axis over here. If I wanted relative frequencies, I'll have to scale off relative frequencies. If I wanted percents, I'll have to scale off percents and label it such. It's very important with graphs to always label them fully and correctly. Never trust a graph that is not fully labeled or that doesn't tell you what's being measured on both axes. Okay, let's go from a bar graph to a pie chart. A pie chart is another graph that you've probably seen in your life. You've almost certainly seen them in newspapers and textbooks. Gets its name because, of course, it's going to look like a pie or a circle. If you recall that a circle has 360 degrees to it, then what we generally do with a pie chart is we use it to show relative frequencies or percent frequencies in each category. Now, in the old days before computers, and when you had to do things like this by hand, if, say, a class contained 30% of the data, then you'd want to make sure that 30% of the pie represented that category. Well, you'd have to remember that since a circle has 360 degrees, that 30% of 360 would be a 108-degree angle, and you'd have to draw yourself a 108-degree angle. These days, computer programs can generally do that much faster than most people can do it. Here is a pie chart for the percent ratings that we were looking at for the restaurant. Again, 35% of the ratings were average, 30% above average, 10% excellent, 10% poor, and 15% below average. In actuality, a pie chart really doesn't give you any more information than just looking at a relative frequency distribution or a percent frequency distribution. But it does have a certain visual appeal to it. Newspapers and magazines like to use pie charts. They tend to grab people's attention. Many firms use pie charts in various areas. One area they use them for is in market shares. You'll sometimes see in newspapers, what share of the auto industry goes to General Motors versus Toyota versus Ford, etc. Firms sometimes in their own individual data use pie charts to show different costs to the firm. For example, what share of our costs is labor cost, what share is advertising, and so on. And that is the end of part one. And next we're going to move on to tables and graphs with quantitative data.